Hello everybody, my name is Asemota, and I'm a pencil partner working on their virtual series learning through Metro Nashville. Last video we took our first look at functions, and this time we'll be looking at graphing those functions into something more physical. Before we begin, make sure to stay hydrated, quarantine yourselves, and get tested if you show symptoms. Now, let's get started. Before we go over graphing functions, let's take a basic overview, a quick look at what functions are. Functions are a system of variables that are made up of independent variables and a dependent variable. It's important to remember that there can be multiple independent variables, but there can only be one independent variable. Excuse me, there can be multiple independent variables, but only one dependent variable. In our case, we're only looking at one independent variable, however, because we're just looking at basic functions to start with. And with these functions, the independent variables are the inputs, and the dependent variable is the output, the totality of the function. That is why there can be multiple inputs but only one output, because you can have multiple inputs, but by the end of your function, there's only going to be one output that sums up all of those inputs. And remember that x is usually taken as an independent variable, and y is usually taken as the dependent variable. And yes, last video I emphasized that it's important to remember this. Even though they can be taken as different variables, it's important to remember that x is independent and y is dependent, and that is important because of graphing. So, how do you graph a function? How do you make a graph for a function? And that is done by taking the points that you've gotten from the table we've made here of the graph y is equal to 2x plus 1. We take these points and we plot them on a plane. Now, a plane is just the domain of the function. It is all the spaces and points that the function exists at. It's just the function itself. That is what the plane is. And depending on how many independent variables we have, the plane will either be 2D, 3D, or a higher dimension. If there is one independent variable, the graph will be a 2D line graph, as we see here in the equation y is equal to x plus 3. It gives us this nice 2D line. If there are two independent variables, however, it will give us a 3D plane. It's hard to see, but as you can see, there are three axes here that represent the three variables in this equation. Y is equal to x plus z plus 3. And each one of these dimensions represent the variable. So when there's only one independent variable, there's going to be one dependent. So that makes two variables as a whole, and that makes it 2D. When there are two independent variables, there's the third dependent variable, makes 3 dimensions. And it's impossible to graph any dimension above 4 because we, as humans, live in a three-dimensional world. We can't comprehend the fourth dimension, yet at least. But let's move on. In our case, as I said, we're focusing on using only one independent variable, so that will give us two variables, the independent variable and the dependent variable. So we're going to be working with 2D line graphs. And when you're graphing a 2D function, you're going to take the inputs and the output values and use them to form a line. Now, how do you do this? Well, each of these values that you get, each one of the inputs has a corresponding output, and these sets of values are going to be 1 point. As you can see here, we have the value 0, 1. How do we know where that point is going to be? Well, we know because in 2D line graphs, the independent variable is always going to be the horizontal position of the point, and the dependent variable is always going to be the vertical position of the point. And this is why it's important to remember that x is independent and y is dependent in most situations, because as we can see with these in this grid, this graph, this horizontal line is the x-axis, and this vertical line is known as the y-axis. And where they meet right here is 0, 0. These squares represent the quadrants that they occupy. This quadrant is positive x, positive y, negative x, positive y, negative x, negative y, and positive x, negative y. And that, or where the points will be, is determined by the equation of the function. So in this case, we see that when x is 0, y is 1. So that gives us the point 0, 1. And to get there, we move 0 steps in the horizontal direction. And since it's positive, it's going to be right. But it's 0 steps in the horizontal position and 1 step up in the vertical position. So that's 0 horizontal and 1 vertical. And similarly, when we have x is 1, y is going to be equal to 3. And so we move 1 step in the x position and 3 steps in the y position, and so on and so on. And when we plot all of our values, we then connect them with a line. As we can see, they're all linearly spaced, and they form a straight line. This type of function is known as a linear function because it forms a linear line in which all the points connect evenly and in a straight line. That is not true for all functions, but it is true for a function if the dependent variable, x in this case, has no special operations such as an exponent attached to it. If it's x by itself or with x with a coefficient, then it's going to be a linear function as we see here. So that begs the question, why do we need to graph a function? We already made a table, so can't we just see values on that? What's the point of doing the extra work of graphing the function? And the answer is, tables are nice, but graphs are nicer. Tables allow us to see the inputs and the outputs, but we have to look at each individual input and output to really understand what's happening in the system, in the function. But with the graph, we see a physical representation of the function in the form of a line or plane if it's higher than 2 dimensions. We see a physical form of that, which really allows us to easily see the relationship of the elements of the variables. And so that's why making a graph is more preferable than just having a table. What could be some real-life applications of graphs? Let's say you are a salesperson selling phones. This is a phone that everyone's going to want. It's expensive. Let's say each phone costs $500, and it's projected and predicted that there are going to be 10 phones sold each day. And what if your boss asks you to calculate the total profit made in a week, and they want you to present your findings to them? Well, let's break down this problem. We know that we're selling phones. Each phone costs $500, and it says that 10 phones are going to be sold each day. And so, what is our independent variable? What's changing? What's changing is the amount of days that has passed. And what we're calculating is the profit. So we know that x is going to be the amount of days that has passed, and y is going to be the amount of money made. And what is x? Well, we know x is connected to how much money is being made each day. So that's 500 per phone and 10 phones. So that'd be 500 times 10. So it'd be 500x times 10, because each phone costs 500 and there are 10 sold each day, and x is the amount of days. And so that gives us the equation, y equals 500x times 10, or you could simplify it to y equals 5000x. And so plotting down the values for 7 days, that's how many weeks is, we get this nice table. We see that by the end of the week we'll make $35,000. But if we want to present that to our higher ups, it'd be better to show them the it'd be better to physically show them the growth that we've made throughout the week. And so if we plotted this down in this in a graph, and this graph it reduces it divides the number by 1,000. So you can see it's 5, 10, 15, 20. That is 5,000, 10,000, just to make the graph cleaner. See, at the start of the week we have 0, and by the end of the week we have 35,000. As you can see, it hits there at 7. And so that's why graphs are needed. It allows us to physically show these things easily. So today we've learned how to graph basic functions. In the next video we'll be taking a look at graphing functions even further. I'm sure you're seeing a trend here. Like I've stated before, math is very fundamental, and it's important to nail down the basics so that you have a strong foundation moving forward. That being said, that's all for today. Remember to stay safe out there, and always train your problem-solving skills. Goodbye, have a nice day.